All right, so let's look at another example of things that we can run into here. So here I've got a problem. We want to find the area of the curve bounded by these three functions, y equals x, y equals 1, and y equals x squared over 4. And you can see them. I've already graphed them. Again, with these problems, you always want to graph them. Use Desmos, use your graphing calculator so you get an accurate picture of what's going on. And so we're trying to find the area bounded by these three curves. And so, of course, that's going to be this area right in here, right? Now, no big deal. These are all functions of x, and so we should just be able to do top minus bottom. But here's the thing, and this is what you want to watch out for, and this is why you need to graph it. You wouldn't notice this without graphing it, is when I consider top minus bottom, then from here, let's do this. From here to about here, this is the top and this is the bottom, right? But from that point, from this point right here to this point, we have a new top and a bottom. And sometimes the tops and the bottoms will switch if you've got curves that are overlapping. So basically, it's not a big deal, but you have to, what you have to do is you have to set up different integrals for the two different areas. So area 1 and area 2, because they have different top and bottom functions. Now, the other thing you've got to do, just like always, is we've got to find these points of intersection so that we know where our limits of integration are. Now, this one's easy. This one, of course, is just 0. But the second one, I need to find basically where this function and this function intersect. So basically, we want to know, to find that first intersection point, we want to know where does y equal x equal the horizontal line y equals 1. And that's pretty easy to see that it's just going to be at x equals 1. All right. So we set the two functions equal to each other, y equals x and y equals 1. So it became pretty trivial. Now, to find this limit right here, this point, now it's the intersection of y equals 1 and y equals x squared over 4. So I want to set up that equation and solve it. Y equals x squared over 4. I'll set that equal to the y equals 1. And so it looks like pretty easy to solve. X squared equals 4. So x equals plus or minus 2. Clearly, we're not talking about minus 2, so we're talking about 2. Once you have those, you're ready to set up your integrals. So for section 1, for area 1, you're going to integrate from 0 to 1. The top function is x minus the bottom function x squared over 4 dx. For area number 2, you're going to integrate from 1 to 2. The top function is now just the function y equals 1 minus the bottom function is still x squared over 4 dx. And so I just have two integrals that I need to evaluate. So I'm going to go ahead and evaluate those off air. All right, so you can follow my work there to evaluate those integrals. They weren't too difficult. Again, the key is to make sure you correctly identify what you have as the top and what you have as the bottom function. Now, if it so happens that you've got functions that are side by side, all of your integrals will be in terms of y, and your limits will be in terms of y. And you just set it up the same way, right minus left. Now, this is an example of a problem we could actually do using the right minus left method. If we view the x squared over 4 as right and the y equals x as left, the integral would look like this. So we'll just write it down here. So not very many of them will be able to be worked both ways. But again, our right function is y equals x squared over, x squared over 4. But we can't, if we're using the right and left functions, we need our functions to be functions of y. So this becomes x equals square root of 4y, or just 2 square root of y. So basically you've got to have it in, and this is what it looks like when it's a function of y. So that would be our right function. Our left function, of course, is just y equals x, which if I, so x equals y, there's my there's my left function. And so when I set this up, I'm going to do right function, which is 2 square root of y, minus left function. And if I look at my, this will be a dy integral. If I look at my y limits, they run from 0 to 1. And so it turns out that doing it right minus left is actually easier. Okay, I'm going to integrate this real quick. And so there it is integrated. The nice thing about doing the right minus left method is you don't have to create two separate integrals. Again, most of these things won't be convertible to both directions. They'll have a natural way of doing it, either right minus left or top minus bottom, but this one does allow for both. Gives you the ability to compare and see how the approaches differ. And of course, we have the same answer, right? We would expect nothing less. But that's the area of that oddly shaped little wedge. So, if you're trying to find areas, of odd shapes, if you can model those shapes by curves, then you can use this approach to find those areas.